on Friday, I became aware, or I had the issue that units that were next to each other had their swords overlapping and their slash. So if we go step by step here, for example, the slash would always be above or behind the sword. And that was annoying. And so I now have a way of fixing that and also having constant frame rate with transparent objects. Here are two trees right next to each other using traditional blending. Okay, first I draw the normal blending objects in the game, and then I draw the additive blending objects. I don't sort between the two, which I could if I wanted to. But essentially, I can also use weighted blending, which I'm gonna explain to you how this works now. So essentially, what is weighted blending? So this is the way it works. We have the renderer or the game, and it sends over data to render. Okay, and that will be stored in some sort of array, you know, which, let's say it's just a bunch of quads. And by the way, it needs to be a bit bigger. So let's make that a bit bigger. Quads. That is an array. Okay. And now what happens is, if we want to have transparent quads and normal quads, the renderer goes in and separates these two. Okay, so we have normal or opaque. Usually this is called opaque, and transparent. And so if we want to draw the transparent quads, what you would usually do is, in a step, you would decide, or you would have like an interleaved list between the blend mode, and then you would decide, you know, you would switch on the blend mode, and then you would draw using depth testing. How do you spell depth? Is it depth testing? And so usually how that looks is like this. Okay, first, if we have an image, we draw the world. You know, let's say we draw the world, and then there's a tree here. We draw it like this. This is opaque, step 1. Okay, opaque. And then in step 2, on top of this image, we draw the transparent stuff. So let's say we have the same image. Let's actually copy that. Okay, we take this. And over here, we draw, I don't know, let's say a sun. Not the background. No, I want to have like a, I don't know. We draw some sort of sun here. And that let's say that's transparent. Okay. So this one right here would be transparent. Okay. And that is the traditional way of doing things. And you know, this is where you would switch between blend modes and so on and so forth. Now, weighted blended, if we put this like this is traditional. Guys, stop it. Remove the emote. Traditional. Wow, look at the O. I wonder what happened here. Lol. And then in weighted, what you do is, obviously, you first draw to this right here. Where is this? What is this called? You first draw the opaque objects. You still do this, but in step 2, and this is the important part, actually, like, why can I not stroke white? Why can I not stroke white? What happened to white stroke? Like, this is such a terrible program. In step 2, you draw to 2 images. Let's see here. V, move this to the left. Pencil. You draw to 2 images. And so one of them is called reveal, and the other one is called accumulation. And so instead of drawing on this directly, you draw to these 2 images, and you still have this one. And so what you do here in these 2 steps, reveal and accumulation, I can show you the math. You think I know what's going on? Hell no, but that's essentially what's going on. You make yourself a new shader and you call it transparent.frag, and then you accumulate, or you build a function. You have like this weight function, which, you know, for those of you math nerds out there you go, that's the weight function, okay? It takes in the color alpha, and then, you know, the coordinate, fragment 0, which is fragment coordinate Z, which is essentially the Y coordinates, or the depth of, it is the depth of the sprite. So, for example, and this is what's stored in accumulation. So, for example, here, if we have 2 pictures, why is this filling in, bro? Like, oh, I see background. I get it now. No background. This particular quad has a position, like a position on the y-axis. Okay? And this is used as the layer, essentially, okay? That's important, because that determines if something is in front or behind. And when we're talking about transparent objects, this is usually, and this is the question, why would you do this? Why don't you just draw over this one right here? Well, because usually not so much in 2D games, but also in 2D games. In 3D games, you have the problem that transparency needs to be sorted, otherwise it looks bad. And so the sorting, you know, when we draw this, the blend mode, before we can do this, we also, and that's the important part here, we have to sort. And that is expensive, of course. This part right here, the more transparent objects you have, the more expensive this operation gets. And therefore you can bottleneck your CPU. I don't know if you can do it on a compute shader on the GPU, might be able to do it, but it still needs to be sorted, okay? And so this is why you would do this, because you can see here that it takes the Z coordinates, the layer, into account. And therefore it generates, using this crazy math function, some accumulation texture that it's then reading later on to figure out what is in front and what is behind. And so what we do here then is, when we have these two images in the third step, and I love how this doesn't give me white as like a color to choose from. Thank you very much. Can I like change default colors or something? It's really annoying. Anyways, so like number 3 is then it takes these two images and let's just keep it simple, right? It pluses them together in a way into the final image. And then that would be this one right here. Right, so we would take this thing and put it together and then we have that. So essentially, if we zoom out a bit, the weighted method of drawing things is more complicated. It requires this additional step number 2 here. Okay, and that is obviously complexity. But what we gain in this scenario is that we don't have to sort. We don't need this right here. And so that's why I wanted to implement this, because I ran into the problem of not being able to draw elements behind each other. So if we switch back, this right here is, by the way, the weighted method. You can see here that the one drawback of weighted blending is that it cannot operate on fully opaque objects, because it still treats it as transparency, and you can see the tree is see-through, which it's not. If we switch the blending mode back to normal blending, it's fully opaque. And so what we have to do here, that's the one drawback, we have to separate out all of the fully opaque pixels from every transparent object that exists in the game right now and draw these in the opaque layer. Which is annoying, but in my case it is actually very easy to do, or very good to do, because I wanted these trees to be fully opaque anyways, because then I could later on turn them transparent whenever I have a fully opaque enemy walking behind the tree, essentially. And on top of that, this is where the testing came into play. We can see here the FPS on the left. It's currently operating at 700, 800, something like that. And this is the normal blending, and I could switch back to the weighted blending. Currently, there's no big difference between the two, right? It's still operating on 700, 800, 900 FPS, depending on, you know, what's going on. And so now I want to test this and try to, like, how do you call that? Try to stress test this, essentially. So what I'm doing here is, on left click, I spawn a meteor, which spawns a bunch of transparent objects. Take a look. And you can see here that the FPS, when it has to work with these transparent objects, it goes down. Right? Let's say we do 3 meteors. It goes down to 500 FPS. But I wonder how many I can do before it starts to break. So if I were to spawn a bunch of meteors, then we could see it goes down to about 500 frames per second. And this is using the normal blending. Okay, and if we switch back to the other blending, let's test if this has an impact. It also has an impact. So in this case, it looks like the sorting is not the problem, actually. But it's probably the calculation for all of these different particles. Which kind of sucks, you know, because I wanted this to be... I wonder where the bottleneck is here, though. Is it the sorting? Let me see here. I might be sorting nonetheless. Let's see. If there is actually no difference, then then we'll have to see what we do, you know. Because I'm using Q sort, which might be very fast. System requirements 4090. Yeah. But it shouldn't have an impact. Which is probably the calculation for the particles. Let me see here. Why does it matter if you're getting 500 FPS, lol? Well, not that much, actually. Not that much, to be honest. Okay, there we go. So this is it here. This is me rendering those, and I'm not sorting in this case. That's interesting. I wonder when the bottleneck starts to happen. So this is essentially sorting. I'm sorting these, and wait, I don't sort the additive blending transforms. I see. I mean, we don't even need to sort these then. Do we? We kinda do. Nah, we kinda do. Doesn't matter, but optimizing your game is still nice. Let me see here. I'm gonna test this really quickly. We're gonna sort the additive blending projectiles, not projectiles. We're gonna sort the additive blending transforms too. And see if there's a difference. Let's see. Let's test. I don't really see a difference, bro. It's quite a few. I wonder how fast you can spawn these meteors. Damn, that's quite a few. Crazy. Seems okay to me, to be honest. I can have 1,000 plus a transparent object, so sorting them would be cringe. If you move, it's more if you're above 300 FPS, etc. When a lot is happening, it's not going to matter. Let me test here. Now we're gonna switch over to the other method. I gained a little bit, but not much. So I'm clicking at the same speed. Yeah, so this one is a little slower because of the sorting. By like 30 FPS, but not much. 30 or 40 FPS, but it's not much. So I might just not use it, to be honest. I mean, it's still nice to have this in the game. But yeah. I might actually not use it. The vast majority of gaming monitors don't go above 120. Yeah, I know. Maybe it causes issues later down the road, yeah. But not now. Can you test during a level with other stuff happening? Sure, but I mean... Holy shit, it actually kills the enemies. Boom! I'm destroying this! Poof! Poof! I think the majority of performance that we leave on the table is updating the particles. Hey! Imagine. So, by the way, this is what I want to have in the game later on as a global ability that you can use yourself. Happy part anniversary there. Thank you, Hermie. I appreciate it. Just work on your game Cakez, you're wasting your time. I suppose you're right, yeah, but it's still learning. I've implemented this in like, I think it was 5 hours on the weekend. Are you always building with O2 or on a debug build? This might impact the CPU performance as well. Yeah, that's true. But like it should, like the sorting should get faster in O2, right? If I were to, like, so, like, I can't optimize the GPU because I'm not building the GPU, right? So the only thing I can optimize is the CPU, and the CPU, that's the bottleneck, that is, or which could be the bottleneck, is sorting the transparent objects. Okay, guys, so for those of you who want to know, because I have put it like as a thumbnail on YouTube, the weighted blending, for those of you who want to know how that works, I'm gonna quickly show you how I did it. Essentially what I'm doing here is we need to generate a frame buffer that we have to specifically define for OpenGL. And so in this case, that is the transparent frame buffer. And that frame buffer has 2 color attachments. And I talked about this earlier. One of them is the accumulation and the other one is the reveal texture. You add those in like this, and then you add these draw buffers to the frame buffer, essentially. And I usually try to check the status after this, and then I also enable sRGB, but these are just specific to me. Okay, so that's the first thing that you have to do, and obviously you also have to have these textures. And the textures that you need to add in order to, you know, these 2 images right here that we talked about, these are defined right here. Normal texture defined, and the image is RGBA 16F. With the size, whatever your game size is, right? So if you have a smaller game size, you can also use smaller textures here. And min and magnum filter, min and min-mag filters are linear. And the other one is just an R8 texture. And for those of you who are wondering how that looks in RenderDoc, or when it's done, this is what it looks like. Let's launch the application. Over here. Guys, stop with the pirate yoink bear, okay? We're gonna press B. This is the actual implementation here, and then we make a screenshot of this. It looks something like this. And by the way, for some reason this looks really bad. Let me change this. Give me a second. Ah! Okay, looks good. Okay, I think that's fine. Yeah. And so this is what it looks like. Actually, I don't like this. Give me a second. Okay, that's better. We first draw the opaque objects in the image. This is storing it in our game, or the picture that we saw. And then we clear those two, the accumulation and reveal textures, and then we draw 2 of those. And one of them looks like this, and the other one looks like this. This is essentially, you know, how transparent each pixel is. Okay, that's essentially what it is. And then we merge that on top of the image. Okay, so we basically take those 2 pictures and we draw them on top of the previous image that we drew. And then we do that again for additive blending. So this is what it looks like. I draw 2 additive blending glows, which are very faint. You can see, you can almost not see them here. It's barely visible. And the other one, the other additive blending quad. And then we also merge that on top of the image. Boom. And then it draws us the additive blending thing. So that's essentially what it looks like. And so we have these 2 color passes in between. And then we just continue on with the normal pipeline, whatever you have. I have quite a few stuff, you know, quite a few things. I also have bloom, stuff like that, just to make the game look a bit better. But essentially that's it, okay? And yeah, I don't think I'm gonna use it though. It was a nice test. Maybe I should have tested a little bit more off stream, but I think it's nice to talk about this. That's essentially how you implement it. So you build these 2 textures, you build yourself the frame buffer, And then you also have to build yourself a program, of course, a shader that handles these two things, right? And let's see here. Where's that? You build yourself a program that takes in a vertex and a fragment shader, and we've seen this, right? In the vertex shader is not that important, but the transparent fragment shader is important. You have your two outputs, the accumulation and reveal textures. Then you put this stuff in here, and you can find this on learnopengl.com, by the way. Everything that I'm talking about here, by the way, you can find it here. Learn OpenGL. It's a very good description of what it does. And if you want to know how it's done or like the finished product, you can take a look at the source code at the bottom. Where's this? Demo. Source code for the demo over here. And then you can just take a look at these different things. It also gives you the shaders right here. So if you're interested in the vertex shader for the fragment, for the transparent shader, you can take a look at those. It opens up these shaders here. It's basically the same code in there. And yeah, once you are done, once you have, set up everything in OpenGL, you have the transparent program and you have the compose program. You then just render this, which is here. Let's see here. You first bind that frame buffer, you use the transparent program, you bind the two textures that you want to output to over here, and then you clear them. I need a projection matrix, and then you just you set the blend mode for these two images. Accumulation uses a different blend mode than the reveal, and then you copy over the transforms and you draw them. And in this case, I'm also composing them at the same time, which is essentially using the compose program together with the game frame buffer, which is drawing to the game essentially. And then you can set the blending mode for that, normal blending in my case. And then we just draw a full screen quad essentially, which is here, binding the two textures, the normal textures, and drawing to it. And that's my wife.